What? You rounded up to what, like 0.17? Fine. And number 7. Now, I put mine in scientific notation, so I have 6.33 times 10 to the 4th PA. If you put 63,300 and something, I just don't know what those last numbers are, because I'm not going to put a number of 63,000 in fixed decimal form. I'm going to put that in scientific notation. And number 9, 389 kPa. Questions on any of those 5? Anybody question on any of those? Okay, because in the gas laws, if you have them converted wrong, it's an automatic standard deduction. There's no partial credit on converting. It's just if you do it wrong in a gas law problem and it's a quiz question, it's a -5. Do another one wrong, it's another -5. Okay? Everybody okay with that? Everybody okay with how to make these conversions? All right. In that case, if you will, find your notes. We're going to talk about 4 gas laws today. I have opted to record your class because there are a couple people in first period who have asked me to record your class because they hate when I record first period class. So I will probably record y'all the rest of the semester. I didn't miss school. Yeah, y'all people are fine. Yes, Riley, I missed y'all. I don't mind spending time with y'all. Yes, Eileen. In a minute, I'm just going to say no. Yeah, Emmanuel turned over a new leaf since we've been back from Thanksgiving. We'll work hard these last 3 weeks before Christmas. Ah, Boardwalk. We've had what, 3, 4, something like that? So Christmas break? Think about that. Oh, interesting. When we get out of school. One, 2, 1 week, 2 weeks, 3 weeks, 3 weeks, and 4 days. So we might as well say 4 weeks. It's only one minus 1 day. So 4 weeks. Yeah, 4 weeks. All right. I hadn't counted the weeks. I just knew we had a while. All right. So Boyle's law is going to explore the pressure and volume at constant temperature. Now, it's not boiler, it's boil. Then first period kept saying boil. Not pronounced that way. I don't think that's it's pronounced boil. I have news for you. I have talked with 2 people whose last name was Boyle, and they did not pronounce their name Boylette. Yeah. Now, all day today, I will abbreviate. Big P is pressure, big V is volume, big T with a little degree of temperature. Now, in the gas laws, I have divided up the way I'm going to teach these into 2 sections. Today and tomorrow, I'm going to teach the gas laws that don't have mass and moles first, and the gas laws that do have mass and moles second. So today, if you look at the board, you've got Boyle, Charles, Gay-Lussac, the combined gas law, and Dalton. I doubt very seriously, even though we tend to work very quickly, that we will do Dalton today. Dalton will be the first thing we'll do tomorrow. Those 5 gas laws are the ones we'll do that do not have grams or moles. After we do those 5, then we'll talk about the gas balls that have grams and moles. Okay? Pretty much. We'll learn how to do. It's not a lot of notes. Just more calculating and listening. There are some notes that you have to write. Yeah. Okay. Yes. Okay. So, but some of the parts of the gas laws are understanding how they work along with being able to calculate. So when we have the test, and I told you 10 were multiple choice, right? Being able to understand how this works is part of the multiple choice. So if we take and consider the gas container, and I put some gas inside the container, I'm just going to draw dots to represent the gas that's in here. Okay? And I'll draw a thermometer, and we'll say the temperature is 25 degrees Celsius. We'll warm the room temperature, so that'll be our temperature. Okay? And I'm going to make it a 1 liter container. Now, before I even talk about what's going to happen with the temperature and the volume and the pressure, tell me this. What creates the pressure inside the gas container? Because in all 3 gas laws that we're going to work with today, you have to be able to explain what happens with pressure, temperature, and volume. If we increase this or we decrease this, what happens to the other quantities? So for today, we're just going to say, let's say, for example, that we change volume. Let's just say we cut this in half and we make it a half liter. Well, what did I say about temperature? Temperature can't do what? It can't change. It has to stay at 25, right? So what's going to happen to my gas molecules in here? Well, I said my gas molecules had to do what? They had to stay constant. They can't change. So what creates the pressure inside the container? Where does it come from? Where does the pressure inside of the container come from? What creates it? What are the gas molecules doing in the container? They're what? They're moving. What are they doing when they're moving? No. What do they do when they move? Huh? Yes, they do. We call those what in chemistry? Starts with a C. No. Collision. They collide. Okay? So the molecules move around and they collide. What do they collide with? Each other and what else? The container wall. Okay? So pressure is created when the particles hit each other and the container wall. Okay? Pressure is created when the particles hit each other and the container wall. All right, so more collision equals more pressure. Does that make sense? Yes or no? Okay, so what can you tell me about our scenario that we have going in this lovely picture up here? What did we do to our volume in Bohl's law? What I do to my volume? I decreased my volume, right? I decreased my volume. So, what do my particles have? More space to move around or less space? I have less space. So, if I have less space now, do my particles have more chance of hitting each other or less chance of hitting each other? More chance. Okay, so I'm going to have more collision. Sort of like when the bell rings at 3:30 on the main hall. Right now, if I sent Eiley up the hallway to go to the office, there's probably a few people on the hallway because fourth period is notorious for people on the hallway during fourth period. But could Eiley get to the hallway right now without hitting somebody going to the office? Yeah, she could avoid them. If there's 2 or 3 people in the hall, she can walk up the hallway and not hit a soul, right? At 3:30, can she get up the hallway without bumping into somebody? Probably not. Why can she not get up and down the hallway at 3:30 without hitting anybody? There's more people, but what else is there? There's less space. So these molecules have less space, so there's going to be more what? Collision. So if you decrease the volume, you have more collisions, which means you increase the what? You increase your pressure. Now, what is that relationship called that we've learned this semester? Inversely proportional. Okay? Very close. I would not have deducted any points for that. Really? Well, maybe. I might not have. I'm doing kind of fault. It's fault. Don't get excited. All right, everybody got it? All right, so Bohl's law says pressure and volume are inversely proportional. At constant temperature. I'm just going to write and moles right there because moles are constant also. Now, the formula for Bohl's law is P1 V1 equals P2 V2. Hello, what's up, Phil? Where's mine at? Mine up here. You know, but I was told about my 4 it's why you bought mine. Yeah. All right, everybody got it? No, they're not. They're fine. We just ran them. All right, everybody got it? Okay. All right, everybody good? All right, what? All right, try that down. Here's your sample. And we're only writing one question per gas wall. Before y'all all go, oh my God, I'm not writing all that. Some of the samples are shorter. This is one of the longest. Okay, and it's only 2 sentences also. And the one for Charles is much shorter, about half that. Pretty simple. For how long? You're only going for a week? You're kidding, right? Are you flying? Well, fine. Anybody take your picture, please? Oh, that's yours. Huh? Right. All right. Well, I don't have any classes for my field trip or first period. During this. What do they call the house to the back to the side? Worst case will be back. It's where a bunch, well, they decorate a house in Lexington to raise money for various charities. All right, so when we look at this, all right, all of the gas laws that we're doing today all work the same way. So those of you who really are good at math, I should by the end of class have board you some, because all of these gas laws work the exact same way. So once you learn the formulas and basically how the gas laws work, you should be home free. Isabel's over there nodding. So this should be an easy quiz that y'all can all make money. Okay? We will have a quiz on it. Not today. But not tomorrow. Because I want Dalton to be on there. Okay? If we have a quiz tomorrow, what things would I put on the quiz tomorrow? If we were having a quiz tomorrow. Really? What was in the opening today? Okay, so kinetic molecular theory, properties of gases, the five assumptions, so things involving the kinetic molecular theory. Notes we did on Tuesday. And what else did we do Tuesday? There we go. Thank you very much, Andy. He wasn't even here, and he knows. What was the rest of you? Now, I didn't say that. I said this wouldn't be on a quiz tomorrow. This would be on a quiz Wednesday. I said if I have one tomorrow, I didn't say. The point is, I'm not going to tell you. The point is, I haven't had one in 2 days. All right, so when we look at this question, okay? I know. We haven't. When we look at this question, what is this? Really should have invested in some backup. All right, what is a milliliter? Is it a volume, a temperature, or a pressure? Very good. All right, so we're going to label it as volume. Now, the thing about all four of the gas laws we're doing today is you have to depend on your English skills. I think Eileen and I only saw four, right? Everybody else, no, I had three. I had three, right? I had John, Sheena, and Eileen. All right, the rest of you are juniors. So, in English class, no, I forgot. I only have two in first period, so calm down. All right, you have to remember your words in English class that show possession. So when you read the word problem, see how the question says when its pressure is 720? That 720 has to stay with the 150. Okay? So that pressure has to stay for that volume. You can make this volume V1 and that pressure P1. I make them V1 and P1 because it's the first volume and the first pressure in the question. However, they don't have to be V1 and P1. They could be V2 and P2 as long as they do what? They stay together. They're a couple. They're a pair because of the wording in the question. 150 when its pressure is 120. See how it shows possession? As long as you keep those two numbers together, it's fine. But I'm going to make them V1 and P1 again because they're where? They're first. Okay? So I keep reading, and it says, what is the volume? So I'm going to be looking for V2. What is the pressure that I see? 750 millimeters of mercury. Now, when I'm solving, before I plug in, there's only one thing I need to do. I need to check to make sure that these units match. Okay? They must match. That's all I need. If the units match, then I'm good to go. Now, at this point, you will hear me refer to these as plug and chug, because that's all we have left is literally plug and chug. So, our formula is P1 V1 equals P2 V2, which is why I say all the time, those of you with stellar math skills, this is the easy part. All you have to do is plug in. So 720 is V1, P1, V1 is 150. You will never see me pick up a calculator at this point. Because I don't care what you have written down at this point. Divided by 750. On your paper, if you go ahead and calculate and you make a calculator error, well, I know what those numbers are. Absolutely not. Am I going to punch on my calculator to figure out where your mistake is? No, it's just a minus 10 out to the side and this wall keeps going. I'm not looking for the error, okay? The more work you show me on your quiz paper when we do the quiz, the more points you get in partial credit. The less work you show me, if you have a calculator mistake, the less points you give me, less points you get from me, okay? I'm not telling you you have to show me work. You don't have to show me anything, okay? However, Alexis, if you make a mistake with the calculator error, and it's a dumb calculator error, when you get your paper back, if you lose 20 points or 15 points because you didn't show any work, will I give you any points back? The answer is no. $144. Now, based on what I just said about the units had to match, all you have to do is go to the V1. What units at the V1? They have to match, so what unit had to be there for V2? Milliliter. Millimeters is the pressure. Oh, it's out of millimeters. I'm getting old, guys. Here's going. All right, everybody okay with that? Can you do one? Fabulous. Everybody got what they want? Page on the page? Okay, when you got it, Alexa. Okay, thank you very much for the compliment. All right, don't write it down. You already have a sample. Just calculate. You already have a sample. Just calculate. Find the answer. Just find the answer. You already have a sample. Just find what you want for an answer. Are we done? All right, we done? Oh, yeah. All right, what do we get? Anybody not get 1,000? Anybody not get 1,000? Just hold up and not get. Nope. Okay. What do we do with that 6.5? Nothing. So it's just information to do what? Throw you off. All right. Charles Law. All right. Charles Law. All right. Is volume and temperature at constant pressure. All right. Charles Law is volume and temperature at constant pressure. So this time, let's say our temperature starts at 25 degrees Celsius. And let's say it goes up to 75. Okay? Let's just say it's 1 liter. And what's it going to change to? Okay, because we're looking at volume and temperature. Now let's catch up. All right, so if I increase temperature, okay, all right, temperature increase. What do we know the particles are going to do inside of that container? That's right. So they're going to do what if they get more excited? They're going to move around more, okay? All right, so if the particles move more, what do they have to do more? All right, they have to collide more. All right, so if they collide more, what has to increase? All right, the pressure has to increase. Pressure must increase. All right. However, for pressure to remain constant, how can we alter volume? Okay, because remember, we said we were going to leave volume, the pressure the same, so that only leaves volume. So in order for us to keep the pressure constant, those particles do not collide anymore often. Think about it. Main hall, 330. You don't want to collide with those people any more often than you have to. How can you keep from colliding with all those people at 330? Well, we can't go around. There's no more space. So how could you get around them? Andy. You need more what? You need more space. So we need a what on main hall? We need another hall. We need another addition. Okay? So, in order for us to fix this, we need to increase the volume and give the particles more space. Because if you guys had twice the hallway space, think about it. If we made the hallway twice as wide, would it be easier to go up and down the hallway without bumping into people? Yes. I mean, you'd still have some butt heads who would go out of their way to bang into you just because they're butt heads. Okay? But most people would be able to look up and go, oh, there's someone there, and go around. Okay? That's why I said there's some people who would be difficult to get along with, but most people would generally go around. All right, so what did we do to temperature? We increased it. And what happened to the volume? Right. So what is that relationship we've talked about this year? Directly proportional. All right, so is everybody caught up? Or do I need to wait? Can I go to the next screen? Okay. So this law, Charles' law, reads pressure. Oops, hold on. All right, volume and Kelvin temperature are directly proportional at constant pressure. I'm just going to write and moles again in parentheses. This time the formula is V1 over T1 equals V2 over T2. Like that. Now, how can you tell, like in the last equation, that there was no pressure? The pressure was constant. If I go back to this formula for just a second, how could you tell the temperature was constant? How could you tell temperature was constant? That's not in the equation. Temperature's not in the equation. The temperature's constant, right? So if I go to what we just wrote on the board, how could you tell the pressure's constant? Pressure's not in the equation, right? So tomorrow, in particular, when we start mixing things up, some people have a hard time with which equation to use. If you read something that says pressure is constant, you want to pick an equation that doesn't have what in it? Pressure. This one doesn't have pressure in it, right? So this one would be pressure is constant. Does that make sense? Okay. Now, tell me this. Why did I have to stipulate Kelvin temperature? Why did I say Kelvin temperature? Can I put Celsius in there and solve? No, I can't, which is why I said. So why can't I use Celsius? Because it's not in. My children love to inform me when I say because. You said I should say the number one. And then I say, give me my cell phone, and then they shut up real fast. Huh? Yes, give me your cell phone. And once I take that, you'd be surprised how much you can clock. Huh? People can die. I think my children might walk through fire rather than give their cell phone. I'm not sure what they would do, but I'm sure there's a very long list. I can't even imagine what y'all do not know their cell phone. Did you survive? Was it painful? Oh, okay. I'm impressed. So, imagine, so, why can't we stop and pull them off? Big math fun. Okay, why? Okay, I got one of those kind of answers first here. I can. I just typically don't. I could. I'm just not going to. I have to certainly catch you. Show the flash line. I don't know what to say. Yeah, we use it more. I said we do, but no. It is, but no. Big math class. What kind of temperatures would we get using Celsius that would be an issue with being in the denominator? Alright, decimals are an issue. At least you're thinking math is this point. Alright, negative number. Alright, if we had a negative number, that's not what I'm looking for, but it's a better answer. If we had a negative number would give us a negative volume. Okay? We're not going to get negative volume. That's the problem. What other number do we not want down here? Think math class. Think math class. Think math class. That's a problem. Whole numbers in the denominator are not a problem. What's a problem in the denominator in math? I thought you were getting ready to say it. What'd you say? What's got to be bigger? No. It can't be one special number that can't be in the denominator. Yes. You can't have 0 in the denominator. You can have 0 Celsius. What number can't you have on the Kelvin scale? 0 Kelvin doesn't exist because that's absolute 0. We've not reached it yet. You're not going to have 0 Kelvin. Okay? So you can't have negative numbers and you can't have 0 Celsius if you're on the Kelvin scale. That's why we use Kelvin. All right. So here's your sample for Charles. Write your one sample down. Okay. He's still on Alaska or is he here? Vegas. Okay. So do you have any relatives still in Alaska? Okay. Okay. Already? Relatively or just? No, okay. So you wear shorts now. Okay.
I remember the first day that I was there.
That would be very hard to do. Oh. Now, were you there during the time of year that it was like fully dark too? Now, was that really weird?
Yeah.
I would think so. Yeah, my children enjoyed the Bruce Gleason stories, particularly my daughter who got her permit in September.
My dad
Yeah. All right, does everybody have it? Now, working the gas law works the exact same way. So, for those of you who are really good at math, at this point, you probably don't need me. Passion has probably already worked the question because it works the exact same way. The rules still apply the same way. Again, look at your possessive word. So when you read 752 ml, what is an ml? So that's V. And at 25 means that 25 Celsius is a temperature. These two have to stay together. Just 1 second. Now, you can make them either both V1 and T1, like I said earlier, or you can make them both V2s and T2s. It doesn't matter. But again, I choose to make them V1 and T1 because they're where? First ones in the question. Yes, Andy. Yes, which I'm getting ready to do in a minute. Okay? Now, as I keep reading, I see the question says what volume? So I'm solving for V2, and it gives me a temperature of 50 degrees Celsius. So, again, just like I said earlier, these have to match, right? And when they match, they also have to be what, Andy? They have to be in Kelvin. So, there's two rules for the temperature. The temperatures have to match, and the temperatures have to be in Kelvin. So, this is why we practiced on Tuesday before break, changing Celsius to Kelvin. So, since there were so many of you out, what's the formula for Celsius to Kelvin again? Exactly. So, for the most part, all you're doing to change that is adding C plus 273. So, 25 plus 273 is going to change that to 298K. 50 plus 2 plus 50 and 273 is 323K. Okay? Now, at this point, what I said earlier is the plug-in chug portion. You know the formula is V1 over T1 equals V2 over T2. So when you look at V1, 752 over 298 equals, I don't know, V2 and 323. And I've said this to you many times throughout the semester. You can solve it any way you want to. If you've got great math skills, do it your way. I don't care how you choose to do it. I only choose to do it which way? I cross multiply. So I'm going to say 752 times 323 equals 298 times V2. To solve, I'm going to divide by 298 on both sides. V2 equals. Now, because I've not picked up a calculator to the very end, do you have any questions about how I chose to punch my numbers in the calculator? If you were looking at my work, would you have any questions about how I chose to punch it in? No. Since this is milliliters here, that means that it's milliliters there. You can round up or down, doesn't make any difference to me. Mine had 815.0, so that's why I put 815. But for the purposes of what we're doing here, let's just say that said 815.9, and I just dropped it off, you wrote 816, I would not get it. It would be fine. Any questions? Want to try one? Because the next one we probably won't even practice it. We'll just do the law and move on. Oh, we need to do this first. I stuck this in the middle because I always forget to do it. So I just slapped the middle of the slide presentation last semester. All right, write that down and then I'll explain. because I always forget to do this. Or at least talk about it, and then I find it in homework, and everybody's like, what is this for? Done? All right. So what does it mean to say STP? If it says STP to word problem, it means they use both apart. Standard temperature and pressure. Now, first of all, you have to memorize this? No. I you put it in with an idea. Okay, how will this desperate even help? You got the blue sheet. If you look on your blue sheet at the front, the very first table at the top, it's got the information in that front table at the very top. You don't have to memorize it. Odds are good by the time you take a test, you will all have it memorized. You will not need to look up anything on that reference table. But in case you have a moment and you just forget, you can always look it up to this day. Okay? Because we'll have multiple formulas and all these different numbers running around. And so this confusing you. You need to look it up. It's like, oh my God, this won't take any test corrections. I might skip one or I might need to look it up, make sure I have the right one. You can do that each day. Okay? After run around Martin Luther King holiday. So, if you read a question that says 752 milliliters at standard temperature, for example, okay, this is telling you that you have a volume of what? If you had read this in the word problem, okay, what would your volume be? 752 milliliters. All right, what would your temperature be that they're giving you when they say standard temperature in the word problem? It'd be what? It'd be 273 Kelvin. So even though they didn't actually say the number, they wrote standard temperature instead of writing 273. You would think it would be easier to write 273 instead of writing out the word standard temperature. They write standard temperature. They're telling you 273. Now, what if they wrote out STP? What are they telling? What are they telling you when they say STP? When they say STP, they're telling you two things. They're telling you pressure and they're telling you temperature. If they say STP, what pressure are they giving? 1 atm. And what temperature are they giving? 273 Kelvin. They're giving you two different things. Okay? So it depends on how they work. You with me on that? Okay. So, yeah. Okay, do that. Now, here you go, there. That's what I want you for. And then we're going to do the last two gap ones real quick. And y'all probably have time to start on homework, which is why I started the video behind. Tell us faster. Long stuff taking you. Y'all get faster. Start it up. I'm done. All right, what'd you get this time? That's the number that rings the bell. Okay. Now, I was hoping somebody would do something like that, so thank you for that. Okay. So, the question said, what is the outside? All right, the question said, what is the outside temperature? Did it specify what unit to use? So what would I calculate it in? I'd do it in Kelvin. Since it didn't specify it, I'd do it in Kelvin. And I'd have left it in that 262K y'all got. I'd take the easy way out because it didn't specify it. I'd leave it in K. Okay? Now, yeah, he tried to change it. No, it comes out in K because when you set it up, you had 2.75 liters, you had temperature of 20, which you changed to 293K. Then you had volume 2, which was 2.46 liters. Then you had T2, which was what you're looking for, right? So when you found the answer, this was 262. They have to match, so it's in Kelvin. No, it's in K. Now, let's talk about this. What if the question had said, what is the outside temperature in degrees Celsius? What if it wanted the answer to be in Celsius? Could you leave it in Celsius and go ahead and calculate it in Celsius since it wanted it in Celsius? Could you do it that way? No. It has to be calculated in what unit? I know, that's why I'm asking it, because where are you going to see it? You will see it, okay? Either on the quiz or the test, I will do it to you, okay? So, if I ask you for the temperature to be in Celsius, you cannot calculate it in Celsius. You have to change it to what first? Kelvins, and then do what with it? Okay, I want it in Celsius. So you calculate it in Kelvins, and then you do what? Use your K equals C plus 273, put your 262 here, and then do what with it? Subtract 273 and change it into your Celsius. Okay, but you can't calculate it in Celsius just because I wanted a Celsius temperature. Okay, you with me on that? Okay. All right. Okay, Lucette. It's pressure and temperature at constant volume. This is the gas law you guys have the most experience with. But I'm sure, because I feel confident, that none of y'all have spent your misguided youth playing with any aerosol can. Any aerosol can. What happens when you heat an aerosol can? It does, rather violently. Okay? If you've never seen it happen, watch a YouTube video. Okay, rather than injure yourself. Yes, you can heat an aerosol can. Okay? Do not do it yourself. Watch it on YouTube. Some other idiot did it on YouTube and videoed it. Just watch it. Rather than taking a chance that you're going to blow off an arm or leg. Or to watch them. Some things are more pressurized than others. That is much more pressurized, it will be a much more violent explosion. Uh-huh. The hazard to that is if you let off on the spray and that flame gets sucked in, what happens? Exactly. Same concept. Just make sure you know what you're doing with that. Now, both of these have to have the same size. You cannot change the size because volume is constant. So, what happens when the temperature goes up? Okay. So, the particles move faster. And if they move faster, what also happens? A what? Why do they have more pressure? Mm-hmm. So the particles move faster, you get more collisions with an increase in temperature. So if we get more collisions, we also have an increase in pressure. So what can you tell me? We had an increase in temperature. Whoops, three lines in the wrong spot. We have an increase in pressure. So what kind of relationship is this one? So pressure and Kelvin temperature are directly proportional at constant volume. And the formula is about a space right there. T1 over T1 equals T2 over T2. Write that up there. Then we try to All right, we there? Everybody got what's in green and the formula? All right, so to make this a little faster on the sample, all right, you can get rid of, no, that is electric. That was not electric. Right. That's right. All right, there. All right, so what do we know? Tell me what we know. Pressure is what? Good. What pressure? What goes with the 3? I got the ATM. I mean, what other number? Okay, what is the 20? Okay, so are we going to call those 1s or 2s? I agree. I'd make them 1s because they're first in the question. All right, what else do we know? All right, the 52 is a what? Okay, so I'm going to make it T what? Fabulous. So what are we looking for? Most excellent. So, are we matching? Very good. All right, so 20 plus 273 is 293K. 52 plus 273 is 325K. All right, so now we're at the plug and chug. So P1 over T1 equals P2 over T2. So 3 over 293 equals P2 over 325. So solving, cross multiply, so we get 3 times 325 equals 293 times P2. Divide by 293, divide by 293, and we already got the answer. I trust you. Anybody else got it too? Only second one I've had today. I cut back to Thanksgiving. A day? No, we'll go.
I really want to.
Over the breakfast, probably at least 4 a day. No. Even I'm not that bad. I could probably drink a 2 liter plus by myself a day. I don't like tea of any kind. That stuff smells bad and tastes bad. I like to taste the tea. Alright, we don't need that, we need this. Alright, the combined gas law is probably my favorite of all the gas laws. Alright? Simply because, A, it combines the three we just did, and it helps those of you who are seriously gas law challenged with remembering the three formulas we just did. Because none of the three gas laws are on the reference table. However, you can get all of them out of the combined gas law. So, the combined gas law combines Boyle, Charles, and Gay-Lussac law. Okay? The only constant is moles. So that's not changing. Moles are still constant. The formula is on the reference table. P1 V1 over T1 equals P2 V2 over P2. Now, same rule as before. The units. Okay, on the top, the units must match. Down here, you must use Kelvin. Done? So, same rules apply as Boyle, Charles, and Gay-Lussac. Pressure and volume still have to match. So, let's say that you're working a question, and your first pressure was in ATM, and your second pressure was in millimeters of mercury. You could either choose to make both of them ATM, or you could choose to make both of them millimeters of mercury. Would it matter which one you pick? Absolutely not. Just pick one and make them both the same. Temperatures have to be in Kelvin. And it doesn't matter which one you choose for the top side. Bottom it does. Now, the reason I like the combined gas law, let's say that for some reason Sheena comes to class, she just has a moment. For some reason, all the formulas have left her brain. She studied so hard, she forgot them. And she's like, dang, I cannot remember Boyle's law. I know it's not one that doesn't have temperature in it, but I just cannot remember. It's gone. So, all you have to do take out temperature, and you're left with Boyle's law. Okay? Say Alexis comes to class on test day. Can't remember Charles' law. But he's like, doesn't have pressure in it. I know it doesn't need pressure in it because it says pressure is constant in the formula. Take out pressure. And he's got Charles' law. Works the same way for volume. Okay? This is the only gas law, or the only formula that we do all semester long that works that way, which is why I like the combined gas law. So you get 4 formulas for the price of 1. Okay? So, we're going to do one sample, and then we're going to talk homework. So write it down, we're going to work it, and then we're going to talk homework. Now, manual popping set up, so anyone interested in looking at that down. Check in on folks. All right, got it? All right, so if we look at the very first thing we've got, the only thing is this is not a couple, this is a triplet. So what is the 50.0 L? That's volume. Okay? What is the 25 degree C? Okay? And what is the 820 mmHg? Okay? Now, again, they have to stay together because of the words of possession. So 1, 1, and 1. You could have made them all V2, P2, and T2 for all I care. Again, I made them all ones because they're where in the question. They're the first. All right, so what is the volume? So V2. What is the 650 mmHg? So I'm going to make it P2. And then the 10 degrees Celsius is, yeah. All right, so again, checking. Does it match? Good to go. This one has to be what? So 25 will make it 298K. And this will make it 283K. So, using our formula, V1 P1 over T1 equals V2 P2 over P2. Plugging and chugging. V1 is 50. P1 is 820. And T1 is 298. V2 we don't know. T2 is 650. And T2 is 283. So I'm going to cross multiply. So I'm going to have 50 times 820 times 283 times 298 V2 650. So, how many numbers do I have with the V2 I don't want with the V2? Well, I'm going to divide on this side by how many numbers? Divide by 298, and I'm going to divide by 650. I'm going to divide here by 298 and by 650. Now, I'll find my calculator and calculate. 50 times 820 times 283 divided by 298 divided by 650. I got 69.9. That's my volume, and the unit is L. Question about any of those. Can we calculate it? As an academic? Yep. All right. Anybody have a question about anything I did or how I did it? I'm going to use the 5 because it's denominated, so it's 5. All right, let me give you your homework paper and tell you which numbers to do. You're doing 6 questions. I would recommend something them like this mark in some kind of way. You know what to do. Remember, if I said homework, you got to have work. All right, the homework numbers you got to do are number 5, number 10,
number 11, number 14, number 16, and number 18.